A 10-gram bullet traveling at 450 meters per second strikes a 12-kilogram, 1.2 meter wide door at the edge opposite the hinge. The bullet embeds itself in the door, causing the door to swing open. And then we're trying to answer, what is the angular velocity of the door after impact? All right, so we have a door, it's hit by a bullet right on the edge of the door, opposite of the hinge, and it goes. So it's important to notice that the bullet is hitting the edge of the door, but it's hitting it right perpendicular. That's important to know, as we'll know, because to find our angular velocity W, we're gonna have to use conservation of angular momentum. And right, since there's no momentum originally of this door, we know the door has 0, but there's momentum of the bullet, right? And it's because since it's hitting it perpendicularly, we're gonna know there will be a velocity. There won't be an angular velocity to the bullet. We're gonna be using a velocity. So I've written down our knowns and unknowns, remembering to switch to do our SI units. Make sure grams to kilograms. And we're trying to find first our initial momentum and then our final angular velocity. So initial momentum is going to be mass velocity times the length. It's being 1.2, so 0.01 times 450 meters per second times 1.2 equals 5.4 kilograms per meter squared. That's the unit. That's why we're changing our grams to kilograms, is because momentum is kilograms meter squared. So with conservation of angular momentum, just like conservation of momentum, the initial momentum will be equal to the final momentum. So we can set that equal to the inertia, because we know it's rotating, times the angular velocity. And since the torque is from where the bullet's hitting it, we know we're going to use the parallel axis theorem, which is going to be the 1/3, using our table, 1/3 12 times 1.2, 12 kilograms, the mass of the door squared, plus the mass of the bullet times the length, 1.2 squared, is equal to our inertia, which is times our angular velocity. We divide the inertia divided by the initial momentum to get our final angular velocity being 0.94 radians.